Okay, so what is really going on here in the main method? What's taking place? Before we can discuss it, I'd like to show you some ideas regarding the user interface organization and its involvement with an operating system and hardware and other parts of the system. So let me maximize this view, and I'm just going to start with the blank form. So suppose that we have a window. Okay, so we have this window. All right. So we have this window someplace on the screen, and it has some widgets, right? Some text boxes, some buttons, radio buttons here, so I don't know, different kinds of controls. And we have the window itself with the title and the Xbox, something like that. So we have a typical graphical GUI, graphical user interface window, right? So anything goes, and many gadgets can be used. Okay, so what we're expecting is that, like we already mentioned, we need an application, right, that has some initialization code, then goes into some kind of a loop, and depends on what the user does, we invoke different section of our code to handle multiple events. So this is our internal organization of an application, which basically is trying to support this window. Okay, and if we have another window, we're probably going to have a similar organization of code for that second window, if we did have a second window in our application. All right, but what is happening in reality here is that if our application executable code is somewhere here, right? So this is, all of these components are somehow positioned in memory, right? We run this program inside our JVM, Java Virtual Machine, right? So Java Virtual Machine provides an executable environment for this graphical user interface application, which runs in support of these windows that we're trying to use with the user. Okay, so JVM itself runs inside the operating system, right? So we'll also have the operating system environment. So JVM is hosted by the operating system, and the operating system, of course, has all kinds of interfaces to the device drivers and basically controls the devices. So here's your display, right, device. Here's your keyboard device right here. Here's your mouse device, right? So you have the mouse. Here's the printer, right? So we have the basically the printer that can print. Okay, then we also can have a joystick over here, right? So some kind of a joystick device with buttons and other controls attached to this. We can also have a flight simulator control like that with some pedals here, so that some kind of a game fanatic could use that for user input and control the whole system. So what is taking place now from this point of view? There are two ways of communication here. First of all, any part of this graphical user program, all of this, could want to send information to this graphical display, right? So we can display new gadget, we could change text inside the text box, we can minimize and maximize our window. All of this can be happening. So basically, all of this would want sometimes to be able to communicate with the physical hardware that displays the information on screen. Additionally, same type of stuff applies to any kind of other output device, right? So many of our components here could try to communicate with printer, okay, just like that. Okay, possible. Then also, when the user is going to start clicking on the keyboard, clicking the mouse, or use this joystick or other input devices, is also unpredictable. So what's happening here, that there is, if this type of communication was going in this direction, right? In the direction to the lower levels of our computing system, basically going to the hardware. At the same time, it's unpredictable when the communication is going to occur this way. Basically, someone clicking the mouse, so therefore the flow of data is in the opposite direction. Basically, the mouse is clicked. Somehow the operating system has to detect that this window is on top of everything that we have. Who owns this window? This window owns Java Virtual Machine, so the operating system will notify the Java Virtual Machine. Java Virtual Machine will see what kind of applications are running and which application is responsible for handling this window, and basically this window is now in focus and therefore should receive the input. So the Java Virtual Machine will basically decide that this should go to this part of our application, and this part of our application should maybe handling the click of the mouse. Okay, so the idea of this picture is that communication goes in two directions, basically up and down. Us trying to display and output information, but also any kind of hardware in any order could initiate the need to handle input from these devices by our window. What happens here is that when these communications up and down occur simultaneously at the same time, it's very difficult to maintain a good state at our a good stable and recognizable state at the application level, at the JVM level, at the operating system level. It's difficult to deal with these messages going up and down if we want to handle all of this executing in parallel. Okay, so instead of all of this, I'm just going to basically clear this up and quickly redraw this. So this is our application, this is Java Virtual Machine, this is the operating system, and this is the hardware, right? So let's reproduce this. So we have our application, we have JVM, we have operating system, and we have the hardware. So the decision which is made by many of these graphic user interface libraries that I was talking about is the following. They say that we are single-threaded. We are not multi-thread safe. We don't have support for multi-threading. We don't have any features built into the thread safety, which means that only one thread of execution could go and execute something that needs to go in this direction, and the same thread of execution will be delivering messages back to our application. In other words, what has to happen is that to make this all work for the user interface, you have to organize this as a single thread of execution. Basically, everything is connected by a single thread of execution, and what it means is that specifically, if you use some kind of a C++ library, you just simply use one of the threads to be your main user interface thread of execution, and just make sure that everything that you do executes on that specific thread of execution. Java Virtual Machine and Java in general, Java platform, made this choice to create this thread of execution dedicated to the communication between the Swing library components, which represents all of our user interface windows, gadgets, and widgets, and therefore use this single thread that manages those graphical user interface components, and at the same time manages all hardware notifications on a single thread of execution. Now, this may have been not really important to us at all, because we could say, so what? We're already so used to single-threaded environment, like in our console window, we knew that our main method gets called on the main thread, and we get this thread of execution for free, and we're now free to do whatever we want, interact with the user, do some computation, and eventually exit. What's different here is this, that when you look at the code right here, when you look at this code, okay, so this is our second sample, but the main method is invoked on your main thread, okay? So what happens here, if we try to picture, if those threads were visible, then our application has this main entry point into our application, right? So main, right here. And guess what? Java Virtual Machine handles threads of execution. So our application initially gets invoked on main thread of execution, and our main method begins to execute. This is public entry point into our application. Then, interestingly, as soon as we include, right, as soon as we include any of the swing components using the import statements here, immediately a separate thread is also created as part of our application. Basically, it's like this. When your application starts, what happens is that Java Virtual Machine creates and invokes this main thread of execution, but it also, and let me just erase this part for now, just get rid of this part right here, right? So Java Virtual Machine also creates another thread of execution, which basically goes into the sleep mode. So once again, I'll erase this, and basically what happens there, that there's another thread of execution which basically goes to sleep, basically hangs there and does nothing, right? Then the rules of the game with swing and graphical user interface using swing, which is standard Java framework to write graphical user interface, says that if you want to create a window, right? Create window. If you want to populate window with controls of some kind, right? If you want to minimize or maximize, if you want to handle keystrokes, right? Like keyboard or mouse, if you want to do any of this, all of this work related to your graphical user interface all together has to take place on this special thread created by Java Virtual Machine specifically for your swing components. So how does this practically how can this practically be realized? If you look at what we do here, look what happens in your main method. So we already established that the main method here is invoked on a thread of execution dedicated to, not really dedicated to anything. This is your main thread of execution. This is basically a thread created in a standard manner by Java Virtual Machine in order to invoke an application. At the same time, we know that somewhere in the background there is a second thread of execution which is now created for us, and so we're now actually in a multi-threaded environment right now. There's a thread of execution which is available to us, but it doesn't do anything, right? So at the same time, in order for us to create a window, create the panel, create buttons, populate, and so forth, and make everything visible, it has to happen on that secondary thread. By the way, it has a name. Its name is EDT, which is event, right? Event dispatch thread. Okay, so EDT thread is the only thing that can be used in order to manipulate windows, including creation of windows. All right. So if you read swing documentation, very quickly you're going to learn that even creation of a window or button or helper objects associated with swing work, all of this must take place on the special event dispatch thread, the second thread of execution. So this is why the idea is right now is that you cannot do all of this. In fact, you could, right? We could do all of this right here directly in the main method. But interestingly, this may be a dangerous proposition, and your code could just crash, could cause unexpected crashes and really strange side effects. So sometimes it may work, sometimes it won't work, sometimes it will be okay, and sometimes it will be just a very, very miserable type of behavior. So this is what happens. Basically, we say that swing utilities is one of the system classes inside swing library, and it has static method named invoke later. So what happens here is that inside swing, part of our application, we have a queue. Okay, so right here, let's just erase this. So the part of our application, we have a queue, right? The queue typically is drawn like this, right? And so the queue can be populated with object. So there is a queue of messages that we can give to this thread to handle, and our job is to place an object in this queue, hoping that at some point the event dispatch thread will be able to get to this request to do something, and will execute its part. For example, create window, populate it with controls, and so forth, right? So look what we do. We said that we have this method named create and show graphical user interface, okay? This is just a simple, normal-looking static method, which has the name, no parameters, it doesn't return anything to the caller, okay? And it's a static method, which is like very simple type of thing to have. So look what we do. We say invoke later. This invoke later method places an object in that queue for the event dispatch thread, and we say that what we'd like to place in that what we want to place inside. Let me just undo what I just did. Use my keyboard. All right. So this section of the code right here basically creates, if I can resize this, right, basically creates an object. It's called an anonymous object. Runnable is, as I think it's an interface, so let's just look this up very quickly online, just to be sure that we're right. So just do my search right here. Okay, a runnable is an interface. Okay, so runnable is an interface, and you can instantly create an object and implement an interface by using this anonymous object in Java. The syntax is that you use your interface or abstract class name. You use the constructor syntax, which uses the set of parentheses. You have to say new because you really want to create the new object, and you instantly override right here. You instantly override a methods, the set of methods which supposed to be implemented in response to using this interface. Basically, what I should be able to say here is override, right? So this is really an override of the method run, and method run basically says that whenever this object is handled, all that's going to happen is that when we look at the picture of our application at runtime, so we say new runnable, this new object gets created and placed in the queue of the event dispatch thread, right? When it comes its own turn to basically to be examined and handled by the event dispatch thread, it simply calls its run method, right? In our case, we say that in our run method, all we want to do is basically call this method. And so what happens is that the event dispatch thread here will say run, and run, of course, will include this, right? Include our create and show graphical user interface method, and this way we simply guarantee at this over here that instead of using the main thread, we would like to delegate this work using Swing utilities, invoke later method, making sure that this code eventually will run on the event dispatch thread dedicated to our Swing interface. And therefore, this is a way it should be happening, and this is the way that Swing needs to be handled. So it's really not that bad, really, if you look at this. This is if you understand what's going on here, it's really not that bad. It basically, you say that I want to create an object by using this new operator, right? And this object will be implementing runnable interface, and this is the syntax for anonymous class in Java. So it's basically, you say, without giving this class any name, I just would like to create an object of that class and have that class implement methods of the runnable interface, which is only one method named run. And guess what? When, like I said, when it's time that this object will somehow be used, this anonymous object, what event dispatch thread is going to do with it, it's going to call its run method. And when it calls its run method, guess what's going to happen? We immediately call our create and show GUI window. Okay, so let's save this segment.